Have you ever really truly thought about what happens to your food after you swallow it? It's not just gone. It's actually the start of this incredible journey, where a meal gets broken down, totally transformed, and then used to power, well, everything you do. So let's follow that path, from the plate right down to the cell.
Right, so that sandwich you had for lunch. The moment you took that first bite, you kicked off this amazing, perfectly choreographed adventure inside your own body. This is the story of how your lunch literally becomes you.
And this is our roadmap for the trip, the gastrointestinal tract, or the GI tract for short. It's basically one long winding tube that starts at your mouth and, ends at the other end. Along the way, we're going to make some key stops at places like the stomach and the small intestine, and we'll meet some very important helper organs too.
So here's the game plan. We're going to break this all down into 4 main parts. We'll start where it all begins, in the mouth. Then we'll head to the main hub of activity, the small intestine. After that, we'll see how nutrients actually get into the body. And finally, we'll look at the super special delivery system just for fats.
All right, let's dive in. Our journey kicks off the very second food enters your mouth. This is where some of the most important first steps of breaking everything down happen.
So, in the mouth, your body launches a two-pronged attack. First, there's the mechanical part. Your teeth chewing, crushing, and tearing the food into smaller bits. And at the exact same time, your saliva releases an enzyme called salivary amylase, which gets to work right away chemically breaking down starches. But here's what's interesting. At this point, fats and proteins are just kind of getting softened up for the journey ahead.
Next up, the stomach. You can basically think of this place as the body's super intense acid bath. This is where things get serious, and a whole new phase of digestion kicks off. Okay, so here's the really cool part about how the stomach deals with proteins. It's filled with powerful hydrochloric acid, but that acid doesn't really digest them directly. What it does is denature them. It forces them to uncoil from their complex shapes. This exposes them so that another enzyme, pepsin, can come in and start snipping them into smaller pieces. And you might be wondering, how does the stomach not get destroyed by its own acid? With a thick, slimy layer of mucus. Yeah, without it, the stomach would literally digest itself. How wild is that? All right, now that our food has been churned into a paste-like substance, we're leaving the stomach and entering the main event. This is the true hub of all the action, the small intestine. But here's the thing, the small intestine doesn't work alone, not at all. As that acidic mush arrives from the stomach, it calls for backup from 2 key partners. The pancreas sends in a whole cocktail of powerful enzymes, and, this is critical, it also sends in bicarbonate to neutralize all that acid. Meanwhile, the liver, with help from the gallbladder, sends in a very special substance called bile to deal with one very specific, very tricky problem. And that problem is a classic one you see every time you look at salad dressing. How in the world do you get oil, in this case fats, to mix with water so your enzymes can actually get to them? The answer is bile. It works just like the dish soap you use to clean a greasy pan. Bile is an emulsifier. It takes these big blobs of fat and shatters them into millions of tiny little droplets. This massively increases the surface area, giving the fat-digesting enzymes way more places to attack. So yeah, an emulsifier is really just a fancy word for something that lets fat and water play nicely together. Without bile, digesting fat would be almost impossible. It's just a perfect, elegant piece of biological engineering. Okay, so the stage is set, right? The acid has been neutralized and the fats have been broken up. Now, a whole army of specialized enzymes can finally get to work. They break down carbohydrates into simple sugars, proteins into amino acids, and fats into fatty acids. I mean, just look at this roster of enzymes. It's a highly specialized team, and each one has a very specific job to do. So everything has been broken down into the smallest possible building blocks. Now what? Well, the next phase is to get all those valuable nutrients out of the intestine and into the rest of the body. This is the great absorption.
But how does the small intestine absorb all this stuff so efficiently? I mean, if it were just a simple, smooth tube, most of the good stuff would just pass right through. The secret is surface area, a mind-boggling amount of it. It's designed to be a nutrient-trapping machine. And it gets this massive surface area through these incredible layers of folding. First, the whole intestinal wall is wrinkly. Then, those wrinkles are covered in millions of tiny finger-like folds called villi. But it doesn't stop there. Each of the cells on those villi is covered in even tinier little hairs called microvilli. When you add it all up, it creates a surface area roughly the size of a tennis court, all packed neatly inside your abdomen. Amazing.
Now, most of these nutrients can pass from the intestinal cells straight into your bloodstream. Easy enough. But fats have one more tricky hurdle to clear. How do you transport an oily substance through your watery bloodstream? Here's the core of the issue. The water-soluble stuff, like sugars and amino acids, they're fine. They dissolve in blood and travel around, no problem. But fats and fat-soluble vitamins, you can't just dump them into your blood. They just clump together and cause a total traffic jam. They need a special transport vehicle.
So inside the intestinal cells, this really clever packaging process kicks in. The fats that were just absorbed get put back together into something called triglycerides. Then, these are bundled up with some special proteins to create a brand new package, a chylomicron. And then, and this is key, these chylomicrons are released, but not into the blood. They take a detour through the lymphatic system, which is like a slow-moving river that eventually merges with your bloodstream.
Chylomicrons are just one type of these fat taxis, and the general term for them is lipoproteins. They're all basically built the same way, a core of fats on the inside with a water-friendly protein shell on the outside. All those other ones you've probably heard of, like VLDL, LDL, and HDL, they're just different models of this taxi service, each with a very different job to do in the body.
And this chart really shows you the difference between them. On the left, you've got chylomicrons, which are almost all fat. That makes them very light or very low density. All the way on the right, you have HDL, which is mostly protein, making it high density. This simple ratio of fat to protein is what determines their name and what they do, from LDL, which delivers cholesterol to cells, to HDL, which acts as the cleanup crew, taking excess cholesterol back to the liver.
Okay, our journey is almost over. Whatever's left of our meal, mostly just water, minerals, and fiber that we can't digest, moves into the large intestine. This is the cleanup phase. Most of the water gets reabsorbed back into the body. The trillions of good bacteria that live here produce some essential vitamins for us, like vitamin K. And that fiber, it helps keep everything moving along smoothly. And that's it. The incredible journey from your plate to your cells. It's a complex chemical symphony with multiple organs, specialized enzymes, and brilliant solutions to tricky problems. And it happens every single time you eat, without you even having to think about it. It kind of makes you wonder, doesn't it? Knowing all that, what are you going to choose to feed this amazing system next?